Hello. Remember when Rutherford fired alpha particles at the gold foil, he discovered the nucleus. Since it worked so well, Rutherford went on to fire alpha particles at everything he could find. So one day he was firing alpha particles at nitrogen gas, and that's when he discovered a positively charged particle. Rutherford immediately concluded that this positively charged particle must have come from the nucleus of the nitrogen atom. And so Rutherford discovered the proton. But scientists knew that there was something else in the nucleus beside the protons. Take for example the helium nucleus, which was found to have the charge of 2 protons, but the mass of about 4 protons. So physicists suspected that there should be 2 more particles called the neutrons. Because if a neutron has no charge, but about the same mass as a proton, then both the mass and the charge of the helium nucleus would check out. Now the neutron turns out to be much more elusive, and it took scientists about 20 years for them to successfully confirm its existence. So after 20 years, we know that the atom is not a boring, uniform, featureless sphere. It actually contains 3 different things: electrons, protons, and neutrons. Now over the years, the mass of these 3 particles have been measured to very high precision. Here the mass are listed in kilograms, but sometimes they are listed in another mass unit called the unified atomic mass, which is defined to be 1/12 the mass of a carbon atom. So 1 mole of carbon atoms weigh 12 grams, right? So if you take 12 grams, divide it by the Avogadro's constant, then take 1/12 of it, you get 1.66 times 10 to the power of negative 27 kilogram. And so there is 1 U, the symbol for unified atomic mass. So now let's see these 3 masses expressed in terms of U. So notice the mass of an atom is mostly found in the nucleus. The electron has a very tiny mass. In fact, the mass of 1 proton is about 1,800 times the mass of an electron. But do you realize that the mass of a neutron is actually slightly larger than the mass of a proton? They are not exactly the same. And it kind of makes sense because later you realize that a neutron can actually be split into a proton and an electron. The electric charge of a proton, however, is exactly the same as the charge of an electron. The only difference is one is positive, one is negative. But magnitude-wise, they are exactly the same. This should make sense, yeah? If not, it's very difficult for an atom to be totally neutral in charge. Okay, that's all for this video. See you again in the next video. Ta-ta!